Hello and welcome to this special feature on software-defined networking. I'm at NetEvents, the place where the press and vendors meet to talk about the issues of the day on telecoms and networking. And one of those key issues is software-defined networking. And we're going to be hearing from Dan Pitt, who's the Executive Director from the Open Networking Foundation. We're going to be hearing from Casey Quillen, who's an analyst with the Deloro Group. He's going to be presenting some new research, and we're going to be seeing a debate about the issues.
Good morning, ladies and gentlemen. I hope you're as happy to be in Miami as I am. I love coming here. I've come here since I was 8 years old and my grandparents retired here. And it's always a pleasure to come back. And especially now since it really is the gateway to Latin America. So I'm really happy to be here. And I look forward to meeting many of you throughout today and tomorrow. So I will be talking about the SDN revolution and the power it brings to the people being the users of networks and those who deploy and operate networks. So I am working with the Open Networking Foundation. This is a full-time job. I'm employed by the Open Networking Foundation. And for the first year and 4 months of our public existence, I was the only employee. Now I brought some staff, and we'll be adding more staff because we're growing faster than anyone anticipated. So the question of why do we have or need software-defined networking?
There's no killer application. Everyone has their own reasons.
Certainly the service providers have ample reasons to want some change in how networking is done. I've shown some here. And I think probably the overriding reason behind all of these is they want to be able to control their own future. They want to make the network do what they want it to do very directly rather than waiting for a very long cycle involving standards bodies and vendors. Our movement is being driven quite obviously by the Web 2.0 hyperscale data center operators, Google for example. These have a direct need and a direct short-term measurable benefit from adopting this technology.
Dan then went on to say that virtualized environments, especially cloud providers, get cost and performance benefits.
And then, of course, wherever you have big data, and we're going to see more and more of big data. In fact, we will need big data to take full advantage of software-defined networking. So with SDN, we're introducing what we call layers of abstraction that for some reason have eluded networking. It's been a trade and not a science. And I'll describe the importance of the open interfaces. OpenFlow is a protocol. I'll show you where it actually fits in and how I define the difference between SDN and OpenFlow.
Dan then went on to compare today's network switches with mainframes. Mainframes are large monolithic boxes that are, by and large, closed and proprietary.
So I'm going to show you this slide, how things sort of evolve from the way they are to the way they will be, just in terms of boxes. Now, there's a lot more than boxes, but this is a good start. We have here today a typical network with one of these networking mainframes. Each one is self-contained and autonomous. There's no headquarters of the network. This is how the internet works, and it was designed this way because back in the 60s, the US Department of Defense, for its own network, said, we need to have a network that will survive a nuclear attack. This is the height of the Cold War. So if anything is wiped out, the others will learn to adjust. They'll find out who's where. They'll figure out what the network topology is. They'll exchange state information, and hopefully they will settle to where we have a network state that is solid enough that you can actually get data through it. So this philosophy served its purpose, but we've really outgrown the purpose. So the first change is let's take this distributed operating system control and all these protocols, and let's centralize it, just in at least a logical way. So we take that out and we make what we call a network operating system or a network controller. And it's sort of in one place, and it has a global view of the network, and it figures out what to do. Now, what about the features? We've got them replicated in every device. The vendors have to put them in there. We talked about the delays. Let's take those out, and let's write them on top of the network operating system. Now, you write them in one place. You have a consistent system-wide view with which you can write these features. So now, if we just have custom hardware in there, it doesn't have to be so custom. It's not running millions of lines of code. You just want to be able to process the physical layer as fast as you can. We've seen the evolution of Ethernet. So we've replaced these with simple packet forwarding devices. And now we have a software-defined network. All these do is process Ethernet packets. So we have features, we have control programs. And what we have really done is separated forwarding from control now. Control is up there, the forwarding is here. This seems revolutionary to us in the datacom world. Wow, we discovered the separation of forwarding and control.
Dan talked about how the ability to program rules such as security policy, quality of service, traffic engineering, and business objectives is a key element of SDN.
So SDN to me is a separation of forwarding from control and a programmatic interface to govern how the network operates through ordinary software. Now, so the network operating system figures out what the routes should be, how traffic should flow per flow, however you define a flow. How do the switches know what to do? That's where OpenFlow comes in. You need an open interface to packet forwarding, and we call that OpenFlow. This is a protocol because it's between two things, and it simply conveys to the packet forwarding devices, to the switches, how to fill what's called a flow table. You define a flow any way you want. If the header, actually, it could be any part of the packet, looks like this, then you take this action. When you separate forwarding from control, you have to have some way for the forwarding elements and the control elements to communicate. That is the OpenFlow protocol. Once you have that in place, then you can have all of this stuff up here. This is where the value is for businesses and operators, being able to program those things in. The value of OpenFlow is that it's a standard way of doing this. You can't really have, I think, a viable software-defined network without separating forwarding from control. And if you do separate forwarding from control, you need some protocol for them to communicate. We have a standard, might as well use the standard. So OpenFlow is a subset of SDN, but I think it's a critical element. So this whole phenomenon happened, like most phenomena, accidentally. I'll describe sort of what the frustration was, but the Clean Slate program at Stanford started working on this. What if we could design the internet with a clean slate? They came up with this. Fortunately, you don't have to have a clean slate. People are introducing OpenFlow capability in SDN, really one node at a time in existing networks. Some PhDs came out of it, plenty of students still studying, and an ad hoc group of people who supported the Clean Slate program from companies and others who heard about it started meeting on Tuesday afternoons at Stanford, and they wrote various versions of the OpenFlow protocol. And people started playing with it, implementing it open source at the student level. And then they said, you know, we got a thing going here. We really should get the whole industry behind it. And they decided to form the Open Networking Foundation. Our goal is to take this valuable research idea and make it a commercial success. Probably the most important thing we did was to introduce IPv6 as a capability of OpenFlow. That came out in December. We are fostering interoperability. We're working on conformance testing, management, and more. So ONF exists as a new organization because, well, the students said, gee, I'm used to programming everything in my life. I can't program the network. What's wrong with this picture? The faculty researchers said, you know, I would like to continue to do research in networking, but I can't. There's no device will process anything other than IP. What if I want to experiment with something that's after the internet protocol? People were actually leaving the field of networking research because it had become derivative. And then the user said, you know, I'd really like a standards organization that meets my needs and that I can drive. And so we were formed deliberately as a new organization.
And it's all driven by users, Dan said.
So we have 7 companies on our board of directors. We have a total of 72 member companies. Its membership is open to anyone willing to pay $30,000 a year. And you'll see we have major data center operators, global service providers. I'm actually pleased we have one of our alternates on the board is in the room, Pradeep Sen from Verizon. He'll be on the panel with us in a few moments. You can see we're quite global in nature, and our representation is very high up in these organizations. This is a very serious undertaking for them. So they devote considerable resources to this. We also have the 2 professors representing themselves who founded this whole movement. Our governance is a little unusual by design. You see there are no vendors on the board. The working group chairs are not selected by the vendors. Sometimes we have vendors, employees as chairs of our committees, but they don't pick themselves. They have to go through an application process to the board. We're trying to standardize not as much as possible, but as little as necessary to make this market go quickly. And especially as we get into software, which is not amenable to the same kinds of standardization. We're based in Palo Alto. We really try to operate like a Silicon Valley startup company, understanding what our mission is, focusing our resources on it, being agile, lean, and fast. Here are the other members. This is a pretty wide cross-section of the industry. You see, we have additional service providers, not just those on the board, from Korea to Turkey. We have every major network equipment provider as an active member here. We have basically all of the semiconductor companies. We have major software companies, VMware, Citrix, Infoblox. We have the 4 main computer companies, IBM, HP, Dell, and Oracle. Why are they here? Because networking is now critical to their computing strategy. Networking will become a part of computing because you're just computing things, you're virtualizing things, you're trying to treat one set of resources in a consistent way for your business purposes.
Dan then talked about how the various working groups within the ONF break down the task of developing a standard into manageable chunks.
Just a few success stories here. You might have heard about Google. The G-Scale WAN connects their entire global data centers. They have the external network and the internal. This is the internal. It's much larger than their external network. It's one of the largest networks in the world. They converted it to a 100% OpenFlow network. They achieved network utilization of 95%. It's way up from what it was before. And these other advantages that I've listed here. Genesis Hosting in Chicago. Such a classic example of multi-tenant hosting. What you want to do, you want your tenants to control their virtual network as if it's their own network. When these things succeed, so that enterprises can trust the cloud providers to give them what they want and give them control they didn't even have when it was their own network, you're going to see many more enterprises relying on cloud services, especially small and medium ones that don't want to have their own IT shop. They had advantages that allow them to serve more customers, improve their margins, and lower their prices and become more competitive. And NTT Communications over in Japan, they're launching in fact, they already launched this enterprise cloud service to be a global service to compete with the over-the-top providers that are doing that. When I talk to service providers, I hear, gosh, I need this to save operating expenses because I just can't afford it. The configuration costs are high. Oh, I need it to save capital expense. The equipment costs are driving me crazy. My traffic is going up and the equipment costs aren't going down very fast. Others say, I need it to be able to introduce new services when I want, how I want. I've got to compete. I'm going to deploy this in a greenfield opportunity like this, and then I'm going to migrate it to the edge and the aggregation and the core. So their infrastructure as a service gives their enterprise clients very, very fine-grained control over their computing resources and their networking resources. So where does this actually take us? I think networking is in for a very fundamental change where it will become part of computing and perhaps become a little less interesting because it will be less of a problem. The programmers are going to be the ones who have the power in the enterprise. People that just configure command line interfaces will need to program. It's configuration by command line interfaces by humans doing this. Number one, it takes time. Number two, it introduces errors. We're going to have so much better automated configuration. So for enterprise IT, and I really feel for the enterprise IT managers, there's no way they can be a hero. All they can do is avoid being a turkey. They can't ever succeed. They can just keep from screwing up. I think this gives them an opportunity to show direct bottom line value to their business via the network. They can differentiate their business by how their whole IT operates. The network operators have a big opportunity. They can become adept at software and managing services, and they can provide the infrastructure, or if they don't move that quickly in terms of software and services, somebody else will, and they will end up being bit carriers. I think we're returning the network to the people that use it and deploy it. Some people have said this is the democratization of networking. I hope that's true. I would like to see that happen. In ONF, we really feel as though we have a high responsibility to move networking into this new realm of usability and programmability for the benefit of those who actually operate yet networks and use networks. Thank you for your attention.
So I briefly wanted a couple data points here. If we look at these are a switch attach rate on servers, and I just kind of wanted to show the speed transition. And as speed is sort of debatable how it fits into this, but what it shows is sort of where we are on the adoption curve for 10 gig, 40 gig, and you see that's starting to kind of happen in the 2013 timeframe. So this is data center forecast for data center switches. We see the acceleration begin in about 2013 as data center consolidation, that 40 gig starts to ramp up. Virtualization obviously continues. And if we look at how that translates into data center switches, right now what we've put together is some information based on Google, some cloud providers, the academic world, what's education doing with SDN, and potentially going forward, what vendors like Cisco adding the OpenFlow client to their switchers, and others who have mentioned, and we will talk more about, have added that potential, added that functionality, and will potentially add more going forward.
And I think this is a very key aspect of this whole move towards SDN is the notion of the programmability of the control plane, right? Which is once you do that separation, once you separate the control plane and the data plane, once you centralize key elements of the control plane by making them programmable, you can then enable a much broader community of developers to go build applications, to go build solutions to the problems out there. Now, what does that really mean? What it means is that you break the vendor dependence model, right? Which is, as IT administrators, as CIOs today, people are completely dependent on their vendors to go solve their problem, right? And we see this all the time, right? People come to us with requests saying, hey, we need these features, we need these capabilities, and we see this from our global customer base. And it takes us a while to go in and solve those problems because we're getting requests from all over the world, right? And so it falls within a certain priority list. And by separating the control plane, by making it programmable, now what can happen is that those problems can get solved by an independent software community out there.
In the past, networks have evolved with focusing on essentially the traffic problem, getting bits from here to there, getting data from here to there. And so all the evolution of whether it's the data plane or the control plane has focused on that. How do we move traffic efficiently from one place to another, get it in the right places, et cetera? And anything above the network, applications have been an afterthought. I mean, you try to not think about applications. You just want to move this data. And if you look at what's been happening in our industry over the years, the value of what a service provider provides has been moving up the chain. The value now is in the services and applications. The bit transport business is becoming commoditized. So what we really need is the ability of services in the network to be more responsive to applications. And I think that's what this separation allows us to do. How do we add value to the network quickly and be able to do it based on our own business needs, not the needs of just, what's available out there from the network equipment vendors. I think that's the difference.
Ralph?
I'd like to raise the discussion up a little bit higher. I think, we're talking about separation of control and data plane. That's more, kind of implementing. If you look at software-defined networking, what it's all about is, getting back to your comment, if you look at your iPhone, the wireless value is like the speed. Is it LTE or 3G? But which is commoditized? It's really the app store, right? That's where people get value, right? And so I think getting back to SDN, it's the programmability, that Dan covered. Can I take this pool of Web 2.0 developers as opposed to network-specific people to do that? A very small pool versus a very large pool. Tons of people can program Web 2.0. And so I think that's really where you really want to focus the effort, whether it's separate control plane, data plane, or the same. There's transport services that don't even use a control plane. They use management plane. The management plane provisions all the connections across the network. So I think we want to raise the discussion up a little bit and say really the objective is to make this very programmable and being able to control the apps to control the network, because today the apps don't control the network, or they're very small custom apps that can do that are very tied by service provider to service provider.
Today, vendors implement software in routers and it's proprietary. Tomorrow, proprietary software will be developed in an offline controller to an open forwarding engine. So the development of proprietariness, in some sense, moves from the hybrid model to a compute controller model. The commercial offering today, in that sense, are closed and proprietary. So I think in time, as SDN matures and ONF potentially becomes a wider scope activity and looks at maybe standardizing the controller to some extent, then we can really look at saying, well, now you have an open control plane that is really programmable.
I want to be very clear about one thing, which is that even if you go down this path, the OS that runs on the switch doesn't go away, right? You will always have an OS that runs on the switch. It'll be doing something different. It'll be doing something less. You won't have all these thousands of protocols running on it, but you will always have an OS. That never goes away. The aspects of modularity, the aspects of network abstraction, all those stay on, right? It's just that certain function now moves out.
Well, I see we've run quite a bit late, so I want to thank the panel and encourage everybody to spend a little bit of time with them if you get the opportunity today. They truly are a brilliant bunch of people who taught me a lot this morning about this topic. So thank you very much.
So NetEvents is over. It was a great keynote. Dan, tell us something, just very briefly, what SDN's all about.
Software-defined networking is a way of allowing users and operators of networks to actually program the networks directly so the features they want can be done exactly as they want them under their control. They don't have to wait for long, multi-year processes to go through vendors and proprietary systems.
So what's the independent analyst's view?
I saw two key takeaways. One is that each vendor mentioned SDN as part of their ongoing strategy. The second was that each vendor had sort of a different viewpoint of what SDN is and how it will impact their business. So as an analyst, we're very excited to see what changes are coming and how SDN evolves over time.
So Dan, I have to ask, given that software is always buggy, that's the nature of software, traditional switches have tended to be robust, so can software-defined networking be as robust as traditional switches?
Actually, Manek, I think SDN will be more robust than the traditional way of doing things. First of all, most of the configuration now is manual and it's very buggy. It's worse than software. Second of all, we really have had 25 years of advances in distributed system software and software engineering that allow us to make very reliable software systems that we rely on every day for our banking and for our personal needs and our business.
Thank you. Casey, let's look to the future now. What do you see as the future of software-defined networking?
Our viewpoint is not that it's going to hurt all Ethernet switch business. We actually think there's a lot of potential to help, provided that the vendors take some time and embrace the technology.
And will it break the traditional business model of switch vendors?
No, I actually see it as an opportunity. I think it changes it drastically, and I think the evolution is going to show how that occurs. But I do see potentials for improvement, and I see potentials for benefits of the vendors as well.
Thank you. So finally, Dan, is software-defined networking going to be as big as you say? I bet you're going to say yes.
It's going to be so big and so ubiquitous, we won't even think about it. In 10 years, if someone says, do you remember when we couldn't program networks? Most people will say, gosh, how did we live with that for so long? I think it will be everywhere.
Dan, Casey, thank you very much indeed for joining me.
Thank you.
So that's it, software-defined networking. You saw it at NetEvents first.